Hi everyone, we are Naomi and Zhang Lu presenting to you our project. In 2030, as technology advances, cooking is no longer a chore but a breeze. We foresee a sustainable and collaborative kitchen where the robot and human work together. Robots doing repetitive or dangerous tasks such as cutting and stir-frying. Human can participate in tasks like seasoning and help in the food preparation stage. This retains the human touch in cooking. In the past, cooking was seen as an arduous task and usually performed by slaves and servants in separate rooms. Industrialization and the rise of the middle class brought kitchen to tiny apartments, and some of the kitchen process has adapted. Modern design, social changes, and a rise in the popularity of cooking shows certainly elevated cooking from a tedious chore to an art. Processes occurring in kitchen include food storage, food preparation, food cooking, food serving, cleaning, and waste disposal. Some of the common kitchen layout arrangements include single wall, gallery, L-shaped, U-shaped, G-shaped, and island. These typologies facilitate circulation and movement within the kitchen. Molly Kitchen is a fully automated kitchen unit that replicates human motions for cooking and is customizable to suit various needs. The Samsung Bot Chef is an AI-powered kitchen assistant that assists humans as they cook. It uses AI-based planning algorithm and voice command. We hope to design a sustainable and collaborative kitchen where the robot and human work together to achieve a life cycle in the kitchen. The robot will be a trustworthy and reliable addition to the kitchen, helping and guiding the user during the cooking process. The robot can also tend to livestock and plants, as well as helping with waste disposal. The food waste can be collected in a compost bin and used as fertilizers for the plants. Our signature dish is stir-fried prawns with garlic. We've recorded the cooking process and analyzed the motion to see which part the robot can collaborate in. We then dissected the steps and mapped out the motions in various tasks and draft out how the robot would perform the same task. These include grabbing and cutting the prawns and vegetables, pouring and stir-fry with spatula, pan movements such as toasting and flipping.
To cooperate with robotic arms, we explore some possible locations and layout design of the robotic kitchen to allow human and robotic arm to work together. It's interesting that unlike human can only stand on the ground, the location of robotic arms can be 3 dimensions. Besides, the kitchen doesn't need to just work in a linear way. The robotic arm can sit in the center and change orientation, so the space can be designed around the robotic arm. We foresee an unconventional, flexible kitchen design that supports both human and robot. There will be 2 arms. One can move and rotate along the central column, called server arm, mainly to grab things, and the other locating on the edge of the top, to move around, called worker arm, to hold knives, choppers, and etc. These robotic arms work together to cover near all working spaces in 3 dimensions. The space is designed accordingly, and people can work on the table as well. There will be a cooktop, a stepped aquatic tank with movable cover, sink, compost bin, and a bar near the vegetable shelf. The bench top can be modified to cater for various needs. Sections show the kitchen space and how it can interact well with human beings, and also encouraging the family to cook together. For the server arm, we only designed a gripper for it which can apply to many conditions, to hold the fry pan, spatula, or the fish net. We also have designed a stir-fry and chopper attachment for efficient cooking and minimizing excessive movement. We mainly have 2 scenarios for this robotic kitchen. One is to cook with 2 arms, get the livestock from the tank, treat it, and stir. The other one mainly depends on the central server arm to take care of vegetables, feed fish and prawns, and serve human beings at the bar. So beginning with aquatic tank, the server arm grabs a fishing net to take the live seafood, and human can check what the net got. If the seafood is satisfied by human, the work arm will use a harpoon to kill the prawn, then changing a special pot to open the back of the prawn while server arm holding the prawn. And we're also showing one more complex motion to toss the pot and turn over ingredients because heavy pans are difficult to do it with only wrist strength. Here are some perspective views and renders for our future kitchen. We hope to have a sustainable kitchen and achieve a life cycle. Food waste can be deposited in compost bins to be used as fertilizer for the plants. Water from the aquatic tank and kitchen activities can be recycled to minimize wastage. The robot can assist in tending plants and livestock, serve, cook, and food preparation, where human can handle tasks such as seasoning and simple food preparations, which in turn preserve the human touch in dishes. That's all for our proposal. Thank you for your kind attention.